Moving on with inverse functions. So we know the definition of an inverse function is by interchanging the x and the y coordinates. And we know visually what happens is basically your graph is flip-flopped over this line of y equals x, this line that we see here. So that's very easy to do when they give us specific points. We can see that all we need to do is interchange the x and the y values, and if that's the case, then we can very easily graph it. But what happens if they don't give us specific points? What happens if they actually give us a function and we want to come up with the actual inverse function? Well, the way that we do that is we follow these steps that I have outlined here. So these steps are going to be the way of obtaining an inverse formula. But before I talk about these steps, let me talk about the notation. So if we have a function that I've called here, we're going to call it f of x. If we want to find the inverse function, the way that we're going to notate it, or the way that we're going to write it, is f inverse of x. Now, I want you to be very careful about what that inverse function means. If you recall back into the exponent section, we knew that if we had anything to the negative 1 power, that means it's the same thing as 1 over x. So a negative exponent is the same thing as a bad attitude, which means that we need to move it to the opposite floor. Okay, this is not the same thing. This negative 1 here is not an exponent, even though that's the way it's written, even though that's what it looks like. It is just a notation. It's the way to write f inverse of x. So don't think that this is the same thing as 1 over f of x. That is not the same thing. What this is the inverse function, f inverse of x. Okay, so now that we know how to notate it, how do we actually find it? Well, if we know that our function is 1 to 1, then we can find the inverse by using these steps here. So if our function starts out as f of x, we replace it with y, which we know f of x and y are the exact same things. Again, it's just a different way that it's notated, so no big deal there. We interchange x and y. And it makes sense why we interchange x and y, because the definition of this was us interchanging the two coordinates. So that's how we find this inverse. Then we go back and we solve for y, and then we replace that y with f inverse of x. So once we flip-flop them and once we isolate our y variable, that's going to give us our inverse function. Okay, let us do this with an actual example. First, we need to prove that our function is 1 to 1. If it is 1 to 1, then we can find the formula for its inverse by using those steps that we just talked about. And then we can graph this function and inverse to double check that we have the right answer. If we graph the function in one color and the inverse in another color, they should match up if we were to fold them over this line of y equals x. Okay, so first, let's prove that this function is 1 to 1. Well, we know that f of x is a line, and we know that the line passes the horizontal line test. So that tells us that this function is 1 to 1. Or you can also prove it formally like we did in the last video. So we know that it's 1 to 1, so now in part B, we actually want to find the formula for its inverse. So I take out f of x and I replace it with y equals 4x minus 5. I switch my x and my y variables, so I have x is equal to 4y minus 5. I want to isolate this y variable, and when I do that, that's going to give me my inverse function. So the only real work that I have to do in this here is when I solve for y. That's the only algebra that we have to do in this problem. Okay, so to solve for y, I move my 5 to the other side. That gives me x plus 5 is equal to 4y. Divide by 4. So I have y is equal to x plus 5 over 4. If you want to keep it in that format, that's fine. Or if we're used to putting it in line format, where y is equal to 1/4 x plus 5/4, either one of those is perfectly fine. So what we have found is the inverse function. So now we replace y with f inverse of x. So we have the inverse function being equivalent to either one of these here. Both of them are going to mean the same thing. So whatever is preferable to you. So I'm just going to use the one that I found last, 1/4 x plus 5/4. So I found my inverse. And now let me graph these to prove that they are in fact inverses of each other. So let me graph my original one, my f of x, for x minus 5 in blue. So I know that my y-intercept is 5, and I know that my slope is 4. So that means I go up 4 over 1 unit. And I'm going to do that as much as I can on this grid over here. So it's more obvious when I graph these to see the inverse of each other. So there is my original function. Now let me graph my inverse function in red. So I see that my y-intercept is 5/4. Well, that is the same thing as 1 1/4. And then my slope is 1/4. So I go up 1 over 4 units. And again, I'm going to do that as much as I can on this grid here, so it's more obvious when I'm going to double check this answer. And so that gives me this line here. Now, if I found my inverses correctly, they should be able to be mirror images over top of this line here, this line of y equals x. So if I were to fold my paper on this line of y equals x, these images should be stacked on top of each other. And we see that they are. So we see that we did find the inverse. Now you don't have to check these by hand. You have a graphing calculator, so you could also check them by utilizing the graphing calculator. So I'm going to do that now. So I have my graphing calculator pulled up here. In my blue, I have my original equation, 4x minus 5. In my red, I have my inverse equation, 1/4 x plus 5/4. And let's see what we get when we go ahead and graph this on the standard window, Zoom 6. So again, the blue is my original equation. The red is my inverse equation. And if I were to fold them over the line, y equals x, do they match? Now, this might be a little bit more difficult to see than when I have it by hand, because I see that my rectangular window is not perfectly square. I see that it's wider than it is tall. So we can fix that with one of two ways. We can push the zoom button, and option number 5, it will square our window up for us, so we don't have that problem going on there. So I push zoom 5, and it's going to make the dimensions wide and tall to be the same one, and then it should be more obvious. So that should help us out there. Or even easier yet, we can graph the line y equals x to see that if I folded it over at that line, would it be exactly the same? And we see, of course, it would be. So this orange is my fold line, and my red and my blue would match if I were to fold my graph over that line. Okay, so we have finished up example 1. I'm going to stop the video here, and in the next video, I'm going to do a couple more examples of this.